And welcome everyone. We will going to be discuss very important topic of data science, which is k-mean clustering and introduction. So we have discussed many things in our previous video. We have recorded the six videos earlier in this playlist. Do check it out those list. Then you will be going to understand this video also. So what is k-mean clustering? And so clustering is an unsupervised learning technique used to group similar data points together. K-mean clustering is a popular algorithm for partitioning data into clusters. It is a simple yet powerful technique suitable for various applications. Basically, clustering means an unsupervised learning technique. Basically, it is used to group similar data points together. Basically, it is a grouping of similar data, nothing else. So now we will learn this K-mean clustering in detail. Introduction to clustering. So basically, what is clustering? The clustering can be divided into four simple points: unsupervised learning, grouping similar data, discovering hidden structure applications in various fields. So basically, what is unsupervised learning? Clustering algorithms learn pattern in data without labeled example. Group similar data. Data points within a cluster share common characteristics, differentiating them from other clusters. Discovering hidden structures. Clustering reveals underlying structures and relationship with data. Application in various fields. Clustering as an application in customer segment, in image analysis, and many more. What is k-mean clustering? Now we will understand about what is k-mean clustering. Initialization. Randomly select k data points and initialize cluster centers. So basically in k means you need to select a random data point and initialize cluster center. Basically you randomly take a cluster and initialize it to the center. Basically a point, then you will align it to a center cluster. Any assignment step: assign each data point to the other close cluster center based on distance. Update step: recalculate cluster centers as the mean of all points assigned to the cluster. You need to update the cluster as all the mean points assigned to that cluster. Repeat step 2 and 3. Iteratively repeat the assignment and update step until the cluster center is established. So basically, you need to in k-mean cluster. What is you basically do? What do you understand by mean? Mean means the mid value. So basically, we need to assign the mid value in the data set. So in the fourth step, we will iteratively retrieve until the midpoint is reached. Assumptions and limitations of k-mean. Assumptions: data is continuous, clusters are spherical, clusters have similar size. The assumptions of k-mean are that the data is similar. Basically, the k-mean cluster assumes that gives us the assumption that the data will be similar in all data sets. Cluster are spherical, so that's the cluster that we made, that we grouped together, are spherical. Cluster have similar size. Basically, all the cluster data divided into different data sets have equal size. Limitations: sensitive to initial cluster center. Basically the initial means the cluster again cluster to the next cluster is very sensitive. May struggle with non-spherical cluster. So the cluster which are not spherical in nature, it is very difficult for k-mean clustering to understand it. Susceptible to outliers. It is also susceptible to outliers. Steps implementing k-mean clustering. So what are the steps to implement k-mean clustering? To implement k-mean clustering, there are basically four steps: load and prepare data, choose the number of clusters, run k-mean algorithm, visualize and interpret results. So load and prepare data: import the dataset and handle any missing value or data transformation. So basically import the dataset that it's had to be created, import it inside the k-mean, and handle any missing value if there is. Choose the number of cluster. Determine the optimal number of cluster using methods like LO method or Silhouette method. Run k-mean algorithm. Basically, run the algorithm of k-mean by using functions in R and Python to execute algorithm and obtain cluster assignments. Visualize and interpret results. Create visualization to understand the cluster structure and draw meaning conclusion from the results. So basically visualize how the model is prepared, how the k-mean cluster is prepared, and conclude the results according to it. Visualizing cluster in R and Python. Scatter plots, heat maps, dendrograms. Scatter plots. Visualize cluster in two-dimensional space. So the scatter plots basically visualize the plots in two-dimensional space. As you can see, this is a y-axis, this is x-axis, and this will show between the y-axis and x-axis. So this is scatter plots. Heat maps show cluster membership using color gradient. We add color gradient inside it, so it shows the clustering by color gradient. Dendrograms illustrate hierarchical clustering relationships. It illustrates hierarchical clustering basically. Evaluating cluster quality. Slaughter score measures how well data points are clustered. So basically, the Slaughter score measures the quality, that how the data is clustered. Within cluster sum of square WCSS measure the sum of square distance between each point to its cluster center. Determine the optimal number of cluster. Elbow method plots WCS against the number of cluster looking for an elbow point where the decrease in WCSS starts to the level. Slaughter analysis calculate the Slaughter score for difference number of clusters seeking the highest average Slaughter score. R world application of K-means clustering. So the real world applications are customer segmentation, image compression, anomaly detection. So customer segmentation group customers into distinct segment based on their purchasing behavior. It basically distributes the purchasers, the customers, according to how they purchase the things. Compare images by grouping similar pixels together. Image compression. Basically, it compresses images by grouping similar pixels together. Anomaly detection identify unusual data points that derive from the normal cluster patterns. So that's all for today's video. We will discuss more important data science topics in our next video. This playlist will be going to an interesting playlist on data science. So stay tuned. If you like my video, please give it a thumbs up. If you have any doubt, ask me in the comment section. If you like my videos, please subscribe to my channel. Till then, stay tuned. Thank you.